Have you ever wondered how you could get your own show on the air? And I don't mean on YouTube, I mean on actual, old-school broadcast television. Well, we're going to find out, and we're going to use the technical manual for a TV transmitter as our guide. It turns out, the whole world of DIY broadcasting is way more accessible than you might think. Let's get into it.
You know this line right here? It's not mine. It's pulled straight from the manual's introduction, and you can just feel the passion from the engineers who wrote it, right? They're not just selling you a piece of hardware, they're basically offering an adventure. A chance to build your very own TV studio, transmit movies, or maybe even run a whole college station.
And here it is. This is the piece of hardware that makes it all happen. The CyberMax TV Plus transmitter. This whole rock-mounted unit is really the engine of our station. It's the thing that takes your video, your audio, and gets it all ready for its journey through the air. Today, we're going to see exactly how this thing works.
So, first up, let's pop the hood and take a little tour of the broadcast's engine room. We're going to see what makes this thing tick, but don't worry, we're going to keep it simple. Okay, this is the main circuit board, the TV Max 8000 Plus. And yeah, I know, it looks kind of like a miniature city with all those components. But for our purposes, we just need to follow the signal's basic path. You know, where it goes in and where it comes out.
So everything kicks off right here, at the video and audio inputs. This is where you'd hook up your computer, a camera, maybe even an old VCR if you wanted. You can think of it as the loading dock for all your content. Your show arrives right here before it gets processed for the broadcast.
And then, after the board does all its magic, combining the signals, modulating them, it all exits from this one spot, the RF output. This is basically the gateway. From here, that signal is ready to travel up a cable to what is maybe the most important part of the whole system, the antenna. Which brings us to our next big point, because the manual makes this incredibly clear. The transmitter might be powerful, but it absolutely cannot do the job by itself. It's just one part of a much larger system, and you need all the other pieces before you can even think about flipping that switch. So here's the checklist of the absolute non-negotiables. You need a properly tuned antenna, you need the right kind of coaxial cable for it, a stable power supply that doesn't fluctuate, a metal case for shielding, and of course, a fan to keep it all cool. The manual is really insistent here. Without these, you're risking feedback, instability, or even frying your equipment. Now, the manual talks a lot about this one specific measurement, SWR, which stands for Standing Wave Ratio. And all this really is a number that tells you how perfectly your antenna is matched to your transmitter. What you're shooting for is a perfect one-to-one match. That means all the power you're sending out is actually getting radiated by the antenna like it's supposed to. And this right here is probably the best way to think about why SWR matters so much. A bad match, or a high SWR, is just like having a big kink in a garden hose. The pressure backs up. With a transmitter, if that signal can't get out of the antenna properly, all that energy reflects back down the cable and can literally cook the electronics. So the takeaway is huge. You have got to get your antenna right. Okay, so you've got your transmitter, you've got your enclosure, and you have a perfectly matched antenna. Now for the fun part. Let's move on to the final stage and see how you actually build this into a real broadcast. It's time to power this thing up and configure the signal. This little control panel is basically your command center. Using just these three simple buttons, up, down, and menu, you can navigate all the settings on this LCD screen. It's how you tell the transmitter exactly what kind of signal you're trying to create. The manual lays out three really important settings for your very first broadcast. So first, you've got to pick your frequency. You have to find an empty channel so you're not stepping on any existing stations. Second, you select the TV standard for your part of the world, like NTSC in North America or PAL in Europe. And third, you set your output power. And the manual's advice here is critical. Always start low.
I just love this analogy the manual uses for the power setting. It's not just an on or off switch, they call it a gas pedal. You can press it lightly for just a short-range broadcast, or you can push it harder for more distance. But, just like in a car, flooring it isn't always the smartest or safest option. It's all about using just enough power to get the job done right. After digging through this whole manual, you start to realize something. Sending out a simple TV signal, something we all just completely take for granted, is actually this incredibly detailed process. It gives you a whole new appreciation for all the physics that are involved. I thought this was great. At the end of one of the sections, the manual has this charming little cartoon, and it asks, "Do you think you can handle it?"
It's just this playful little nod to the fact that, yeah, this stuff is complicated, but it's also a really rewarding challenge. It's like a little call to action for anyone who's curious and determined.
And that's really the big takeaway here. Broadcasting isn't just one thing. It's a whole system. It's this delicate balance where the antenna match, the physics of keeping things cool, and all the engineering of broadcast standards, they all have to come together perfectly just to send one single clear picture through the air.
Which really just leaves us with one final thought. If you had the power to put anything you wanted out there on the airwaves, from your living room to your entire neighborhood and even beyond, what would you broadcast on your own TV station?